see a lot of our network teams that are spending tons of their time, nearly half of their time, on troubleshooting from a lot of network IT departments that we've surveyed. Some of the key challenges here is collecting information, taking a phenomenal amount of time, and then unable to replicate. A problem is reported, but by the time, somebody starts investigating it, that problem may not be manifest anymore. And so how do we deal with that? So this is what we're going to be talking about, a tool to address this business challenge, and it's DNA assurance. And the whole business value proposition here is to free up your time. Don't be spending 43% of your cycles troubleshooting, but allow that IT talent to be used into something more strategic and innovative, and then drive business transformation as a result.
That's Cisco Press author and principal engineer Tim Szigeti. In this episode of the Cisco Learning Network Podcast, Tim will explain the need for DNA assurance in today's business environments and begins by discussing some of the issues and challenges the typical network faces. Tim then covers how those challenges and issues affect individual employees from the frontline analyst to the expert, giving more reason for the demand of DNA assurance. In addition, Tim will provide context for these issues by discussing how the network evolved to this point and by examining how machine learning plays a pivotal role in the development of networks in the future. Tim recently spoke in a DNA Center Training Videos webinar hosted by the Cisco Learning Network and begins by covering the main people DNA assurance is for.
Some of the main points I'd like to cover, I'd like to share, first of all, why we built this product, who we built it for, and then, the product itself, the technologies, and what it can do for you. So with that, starting with the business value, troubleshooting networks is just incredibly complicated. There's so many things that can go wrong end-to-end, wireless, over the wired network, application servers, connecting with providers, and so on and so forth. There's a lot of variables in this end-to-end equation, and then trying to figure out, what's going wrong, finding and isolating that problem area, and then ultimately remediating whatever is the cause of the issue is the challenge.
In Tim's presentation, he displays a slide that asks the following questions which have to be considered when troubleshooting a network. What is the problem? Where is the problem? And how can I fix the problem fast? In another part of the slide, a data point is displayed that states that there are over 100 points of failure between the user and the app.
We see a lot of our network teams that are spending tons of their time, nearly half of their time, on troubleshooting from a lot of network IT departments that we've surveyed. Some of the key challenges here is collecting information, taking a phenomenal amount of time, and then unable to replicate. A problem is reported, but by the time, somebody starts investigating it, that problem may not be manifest anymore. And so how do we deal with that? So this is what we're going to be talking about, a tool to address this business challenge, and it's DNA assurance. And the whole business value proposition here is to free up your time. Don't be spending, 43% of your cycles troubleshooting, but allow that IT talent to be used into something more strategic and innovative, and then drive business transformation as a result.
In Tim's next slide, he displays two additional points. The first is that network operators spend 4 times the time they do collecting data than analyzing while troubleshooting. The second is that most network quality issues take hours to either resolve or prove the network innocent.
Our overall network-based, intent-based networking model is based on 4 pillars: functionality, to take high-level intent, translate that into the policies across the network, to have pervasive security at every stage and every layer. And then the 2 key areas that analytics and assurance address is context and learning. So I'm going to dive a little bit deeper into what I mean by these, because they're fairly abstract terms, but I want to make them more real in the discussion. So let's take a look at, first of all, context. What do we mean by context? Well, troubleshooting a network or just gathering all the information, network data information, is a lot like connecting the dots. You can have a tremendous amount of data, but what does it mean? Until you start connecting things in a logical manner and correlating related data points, then patterns of meaning begin to emerge. And this is then the goal here of analytics, to basically take all of that data that we can gather from the network and adjacent sources and extract, convert meaning extract meaning from it or convert it to meaningful information, however you want to think of that. Some of the challenges here is that there's a tremendous volume of data. Over 1 terabyte a day can be generated on most enterprise networks. It's coming in incredibly fast, and so to be able to deal with this in a real-time or near real-time manner, there's so many different formats of all this data. So like for instance, legacy SNMP and syslog to newer forms of telemetry like streaming telemetry and NetFlow even. So having a way to compare apples to apples. And then the veracity of the data. It's like not all data sources are equally accurate. And I'll give an example. I can get packet loss statistics, for example, from interface counters, and I can also get packet loss statistics from, say, IPSLA or even ping. But the interface counters are going to see all the packets, and they're going to give me a much more accurate report on the packet loss, whereas a ping or a traceroute operation, if I drop one packet in 5 in a simple ping, it's going to report 20% packet loss, whereas that single packet that was dropped may be just 1 in a million that was dropped. So we have to also account for the veracity of the tools. Then basically the challenge is to say, okay, let's convert this data into something that you can understand, that gives you insights. It'll tell you what's going on in your network, and then ultimately we want to tie that to remediative actions. So let me give an example.
Tim moves next to a slide that displays a pyramid divided into 4 layers. From top to bottom, the 4 layers are labeled action, insight, information, and data. Next to the bottom layer, data, Tim includes the fact that WebEx has 63 milliseconds of jitter.
We're using WebEx. Have you ever had a poor experience in WebEx? Well, shockingly, some of our customers have. So we could start by this. We gather network data, and by comparing the timestamps of packets, we can calculate jitter. That's very light processing of data. But if we get a report that says, hey, WebEx has got 63 milliseconds of jitter, is that good? Is that bad? Should I be concerned? What do I do with that? Well, this is where we convert that into information, something that's more meaningful, something that's more consumable by our end users. We'll say, okay, we'll represent that in a more abstract way. We'll say it's a health score, and then we'll say, look, this isn't perfect, but it's not that bad. But if you want to maybe dig a little deeper, you say, well, why? Why is it not perfect? What is dragging it down? And where is that happening? Well, this is where an insight we can offer. You say, okay, well, actually, this is happening on your wireless LAN, and we can even offer a specific recommended action to improve or to fix or to address, remediate that issue. So this is what we're talking about. Well, how do we do this? Well, let's take a look at an example. It's the same example, but from a technical level. What do we need to make this happen?
Tim displays a workflow next to illustrate the contextual correlation he's been referring to. In the first section of the workflow are the departments represented by rectangles labeled with terms like NetFlow, AVC, location, device, ISE, and so on. These rectangles all feed information illustrated by arrows to a section called the analytics engine. This department then points that information toward an icon indicating the culmination of what can be known about the user.
Well, let's say a user calls in, George Baker, and he says, okay, I've had a poor experience with WebEx. Well, we gather information from the identity services engine, and it will tell us who this user is, what groups he belongs to, what devices he has on the network, and even the MAC addresses. That's a great starting point, but now we need to correlate. We need to connect some dots. We gather information from our DHCP, our IPAM, our IP address management infrastructure, specifically the dynamic DHCP infrastructure, and we say, okay, well, what is the IP addresses that correspond to these MACs? And we'll ask George, we'll go, well, was your experience on your iPhone or was it on your PC? You might volunteer, it was on the PC. Okay, so let's find out what the current IP address of your PC is. Let's then filter all the NetFlow records that we've ingested across our entire enterprise by that source IP. And now we know all the streams that belong to George from his PC, but we're still not sure which one is WebEx, so we have to use another technology, our application visibility and control. And now we can identify the flows that belong to WebEx. And we can also then correlate that with information like where is he attaching to the network and what is his path across the network from that client to the WebEx servers, so we know all the network devices involved. We can also complement that with geography information, like what building is he in and what floor and so on and so forth. And then ultimately we want to also tie in information that we get from the network itself, like what's going on, what are you reporting, and what have you analyzed. And so here we've come to the root cause is that, okay, he doesn't have any layer 2 QoS markings. The IEEE 802.11 user priority markings are absent. Very, very common issue. Second most likely place of poor application performance, latency and jitter being induced in the enterprise is on the wireless LAN edge, and that's what's happening for George. But this is, again, just an example of how we've connected data points, correlated them from across various points to arrive at this answer. Now, to complement context, we also have learning, and so this is machine learning that we're talking about. Machine learning at a very high level is AI, artificial intelligence, algorithms that basically look for patterns in the data.
Tim moves next to a slide reminding the audience of what machine learning is at its core. He displays the definition. Machine learning is an application of artificial intelligence, or AI, that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed to do so. Below that is another point, which reads, the process of learning begins with observation of data and looking for patterns within the data so as to make increasingly better correlations, influences, and predictions.
It's beyond any human ability to analyze all the possible ways that the data can correlate or all the causations from all the variables in the network, whereas if machines pore over this data, they can identify patterns. First of all, the machines can identify these patterns in a completely unsupervised manner or by guided human supervision, and I'll illustrate what we mean by that. Now, if there are patterns in the data, there's three reasons. It could be just pure dumb luck, coincidence. It could be correlation, but correlation is not the same as causation, and it's important to understand the distinction between the two. For those that have taken statistics, you're probably familiar with this maxim that they pound into you very early on. Correlation does not necessarily mean causation. Just because two data points might have a relationship doesn't mean that one causes the other. And here's an example. I kind of like this, it's a humorous example.
Tim moves next to a slide that displays the reasons for data patterns, which includes coincidence, correlation, and causation. But in addition to those reasons, Tim has also displayed his example with a graph to illustrate his point, which is that correlation does not necessarily mean causation. The title of his graph reads Global Average Temperature versus Number of Pirates. This graph is exactly what you'd expect when you think about the global average temperature of the world over the past few centuries compared to the number of pirates that exist in the world. As the global average temperature goes up, the number of pirates goes down.
Here, if we correlate the overall global temperature over the last few hundred years, I guess, a couple hundred years, with the number of pirates that are living in the world, and I'm not talking about like data pirates or hackers or this and that, I mean like the actual like Shiver Me Timbers, Jolly Roger pirates raiding on the seven seas and stealing gold, we'll see that there's a very strong correlation. As the global temperature is gradually increased, the number of pirates have died off. Is this a causation, though? Well, I don't think anyone would really think it was because, it's a ridiculous example serving to illustrate a point. But if it was a causation, then we could reason along the lines that, global warming is killing pirates, and therefore, if we want to address global warming and bring those temperatures back down to where they were, maybe we should just encourage more of our kids to pursue a career in piracy, and we'll solve that problem. So the key point I'm making here is that correlation is not causation. However, as these AI algorithms pore over the data, the ultimate goal is to find those causations, to look for the patterns, look for the correlations, and ultimately, if you can find the causation now, you have an answer of why something is happening, and that provides you with cognitive analytics. That is the explanation of why something has occurred, as well as it gives you the ability to do predictive analytics, to predict something that's about to happen. Hasn't happened yet, but you see the causes forming that will ultimately lead to an event happening, and therefore you could even take preemptive action to prevent something from happening. So then machine learning, we bring in tons of information from all over the network. We run these very complex algorithms, and then we identify these issues. So I'll talk a little bit about that as well, and I'll show you some demonstrations. Before I go on there, I do want to talk very briefly about user requirements, because this is a major philosophical change in approach that Cisco has made, and that is by really not just focusing on technology, but placing equal emphasis on the users.
Tim advances to a slide next that displays 3 circles in a Venn diagram style, with the circles overlapping each other in different ways. One circle is labeled human, another technology, and the last one business. At the center of this diagram of human, technology, and business is a section in which all 3 circles overlap. That section is labeled design thinking.
This is not something we've always done in the past. In fact, candidly, I don't think we've ever really done that to a significant degree. But with DNA, this has been a very intrinsic part of the overall design process. And so we conducted literally hundreds of interviews, the majority of which were blind, with users. So they didn't know who was asking the questions, asking them about what are their challenges in running their networks and who's running their networks, to really understand the users, their pain points, to be able to address, what their needs are and how best to enable them. As a result of these discussions, we had a number of archetypes or user types, very common users that we found across the industry, and begins with the frontline analyst.
The next slide in Tim's presentation displays something similar to a profile card, showing the picture and information detailing a person. In this case, the profile card shows Ted, the 21-year-old network ops employee on the front line. This profile card displays many factors about Ted, including his responsibilities, needs and motivators, and pain points. But it's the details of Ted's pain points that Tim has highlighted in this slide, including specific points like penalized if they don't use the right tools when they don't all know how to use them, or penalized if they don't escalate to the right expert due to misinformation, and penalized if they don't escalate in a timely fashion.
This is typically the first person, and there are more of these people in a given organization than any other type that we're going to discuss. And these are the ones that are like the trial by fire, learn to swim by being thrown in the water, the first person to pick up the call. And they have very little training, very little expertise, but they get a lot of pain. They get penalized if they don't know what to do. They get penalized if they don't escalate right or quick enough. Incidentally, I started my role at Cisco about 20 years ago, actually just over 20 years ago, as a frontline analyst. So I do have a lot of empathy for these people. They spend the vast majority of their time troubleshooting, and some of their descriptions, and again, these are customer descriptions, we're not making this up. One customer describes their analyst as train monkeys looking for red lights. They don't really know what else, but they know that if they see something in red, there's a problem. Now, what's really interesting is a common theme that we've seen over and over is that a lot of times it's not the network that's at fault, but it's typically the first to be blamed. And so a lot of time is being spent just proving it's not a network problem. The next level of user is the level 2 analyst, and his complaints are there's too many things coming to me that should have been dealt with at level 1.
Tim moves to his next slide, which displays the profile card of Charles, the 27-year-old network engineer. Similar to Ted, the frontline analyst, Charles has certain details highlighted in his profile. This includes a couple of quotes, one which reads, "I don't want to be a data scientist, I'm a network analyst," and another that reads, "Tell me if an event is normal."
And so he's basically not effective in his job because he's getting all this work escalated to him that shouldn't be. His real asks are, I don't want to be overwhelmed with data, just tell me if something is normal or not. And then the next level is the T3, the expert, which a lot of us likely on these calls are. And again, they have the same complaint. There's too many things being escalated to me that shouldn't be. So this common theme of, hey, if you can make those frontline analysts more effective, it will have a trickle-down effect on the entire networking IT organization and allow them to be more effective in their jobs. And again, even this guy here, he's saying, I'm spending a lot of time proving it's not the network. And because of his impact to the organization, this is really valuable time that's being lost here.
To hear more from Tim Szigeti, or to view the full webinar that this segment is from, be sure to visit the Cisco Learning Network at www.ciscolearningnetwork.com. You can also visit the link in the description, which will take you to more training videos hosted by the Cisco Learning Network that lay your foundation for DNA Center training. The Cisco Learning Network contains all kinds of resources to help you get started on your networking career, including additional training videos and study groups that allow you to connect with others trying to get started in their networking careers. Please subscribe to the Cisco Learning Network podcast and be sure to leave us a review on iTunes if you found this helpful. Thanks for listening.